Alright, welcome to this video. We have 5.7, rational exponents and radical expressions. So go ahead and title your notes. Go ahead and copy down this property. We have x to the a over b equals the b root of x to the power of a. And I'll explain what that is. So what you have here is you have x raised to an exponent, but your exponent is a fraction. It's a over b. And a and b can be any numbers. And you can rewrite this. Well, look at what happens is the a is on top of the fraction here. So it's your numerator. Well, that is your power. So a is what we call your power on x. The b is on the bottom, and b is the root of x. So this looks like a square root, and it is, except it doesn't have to necessarily be a square root. It could be any number root we want it to be. And we'll see more about what I mean by that a little bit later. So we're not limited anymore to square roots. That's what we're trying to say here. But speaking of square roots, we do have a special case that when you have x raised to the 1/2 power, that's the same thing as the square root of x. So these are interchangeable. If I ever see x to the 1/2 power, I can replace that with the square root of x. And vice versa. If I see the square root of x, I can replace that with x to the 1/2. So let's go ahead and use that property that we just saw, and let's go ahead and rewrite these problems using radical notation. So I have here, because I have a 3 right here, this is called our index. We call this the cube root of 11. Now, if I go by the property, I also need a power. I have my variable raised to a power, or my number in this case. Now, I don't see a power written here, so I'm going to go ahead and put a 1 here, so I know that it's there. So now, to rewrite this, I have the 11, but because there's a 1 here, it's raised to the power of 1 over my index, or my root number, which is 3. And that's how you rewrite this. So let's go ahead and try it right here as well. So I don't have a power written here. I'm going to put a 1 here. And because I have no number written here, this is that special case where if I don't have anything written here, it's a square root. So it's as if there's a 2 here. You don't have to write the 2, but that's what it's saying. And so what happens is, to rewrite this, I have the 3. I have it raised to the power of 1 over 2. And that's how you rewrite it. Let's go ahead and try this one out. So this one, I have the 20. Bring the 20 down. Here, I do have a power of 1. So I'm going to put that 1 right here. Over the index, or the root, which is over 7. Good. So that's that. And this is just going backwards now. So we're going to rewrite this using rational exponent notation. By the way, the word rational, another word for the word rational, a lot of people like to use the word fraction. And that's what we're seeing here. We're seeing exponents with fractions. Alright, so we have 3 to the power 7 and the 5th root of that. So we have the 5th root of 3 to the power 7. We want to go ahead and rewrite this as 3 to some fraction or rational exponent. So I'm now going to have a fraction here. On top of the fraction is going to go the power, which is 7. And then on the bottom is going to go the 5. Right here, I have 15 raised to the 3 over, then what number do I get from here? If I have no number written here, I assume it's a 2. There's a 2 assumed to be written here. Okay? What about this one? So I have the 10 raised to the power of 2 over my index, which is 4. 2 over 4 can reduce, actually. So we're just going to go ahead and do that. 2 over 4 becomes 1 over 2. And that is the final answer for that one. I have the square root of 7. Well, this is really 7 raised to the power 1. What number do we assume is right here? It's a 2. So the way to rewrite this is 7 to the 1/2 power. There you go. Moving on. So what I've created here is a chart. And this chart, what n represents is just your numbers, starting at 0, 1, 2, 3, and so on. And then, the list can go on forever. And I've created other columns based on what n is. So this says n squared, which means that this column is going to be our perfect squares, and we already know that. We've seen this before, perfect squares. So if I have 0, if my n value is 0, what is n squared? Well, that's 0 times 0, which is still 0. Same thing here, n cubed, that's 0 times 0 times 0, which is still 0. Same thing here, 0 times 0 times 0 times 0. But let's see what happens when we go beyond 0. Well, actually, 1 is also pretty easy because no matter how many times you multiply 1, you'll still get 1. But let's see what happens when we do 2. Well, 2, n squared would give us 2 times 2, which is 4. 4 times another 2 is 8. And then I would have 16 here. So I just want to go back real quick. We call this column perfect squares. This is the ones we've seen before. Actually, we've also seen perfect cubes. That should not be new as well. But we also have what's called perfect fourths. You can have perfect fifths, perfect sixths, and so on. We could, not only could we go forever going down this way, we could go forever this way as well. In our class, we'll probably not go beyond power 4. We may see a couple powers of 5. In fact, let's go ahead and let's actually add an n to the 5th column here. So what would come after the 16? That would just be another times 2. 16 times 2 is 32. So again, what does this mean? It means that 32 is it's really just 2 to the power 5. This is really 2 to the power 4. This is 2 to the power 3. This is 2 to the power 2. Let's go ahead and just keep filling this chart in. So here I have 9. This is 3 times 3. Here I have 3 times 3 times 3, which is 27. Here I have 3 times 3 times 3 times 3. That turns out to be 81. This is 3 to the power 5 right here. So it's 3 times 3 times 3 times 3 times 3. And you get 243. I'm just going to go ahead and fill in the rest of the chart if you want to go ahead and go with me here. I'm going to go by columns here. So 16, 25, 36, 49, 64. Here I have 64, 125, 216, 343, 512. For my perfect fourths for 4 is 256. For 5 it's 625. We'll stop there. I don't think we'll see. I'm putting the ... to show you that the list could go on. I don't think we're going to see anything beyond 625 though, to be honest. Let's put 1024. That's the perfect fifth for when n equals 4. But we're going to stop there as well because I don't think we'll see anything beyond that for perfect fifths. Alright, so there's a chart. You should know, at least for perfect squares, beyond 8. If you had 9, your perfect square would be 81, right? Because 9 times 9. But honestly, I know you guys know that already. We're going to go ahead and evaluate these using a calculator. So we all have different calculators. Mine might be different than yours, and that's okay. I'm going to show you how to do it on my calculator. And if it's different than yours, just at some point in class, make sure you come see me, and I'll show you how to do it on yours. It's no problem at all. So what we have here is we want to evaluate each of these using a calculator, and we're going to round the two places. So we'll start with we say this as the cube root of 60, the cube root of 60. In my calculator, I'm going to turn it on, my radical sign, I'm going to try and zoom in here, my radical sign is right here. That's the radical button I want to use. Well, actually, that's only for square roots. I don't know if you see right above it, but it has for cube roots. So to get that, I'm going to have to hit Shift. See how it pops up on my screen. I type in the 60, and then I hit Enter, and it gives me a decimal. And I sit around the two places. That's two places after the decimal. So I have 3.9, and the 4 is going to keep a 1 right here. So we have 3.91. That's our answer right here. Right here we have the fifth root of 7,003. The fifth root, now where do I have that at? On this calculator. Because right here, I have square root, and right above it I have cube root, but where's fifth root? You know what? If you go two buttons over and look above that, do you see it has the radical sign, but with two boxes? That's what we're going to use for fifth root. So to get that, I'm going to have to hit the Shift button again. So hit Shift, and then hit this button. See, on my calculator it pops up with an option to put a number here. That's our root, and then the number inside. So our root, we're doing the fifth root of 7,003. So for the root, I want a 5. Sorry, I was turning off my fan. It's blowing my papers too much. Okay. So I have the 5 inside. Oh, sorry, on the outside. And then I have, on the inside of the radical, I have 7,003. So type it in. Gives me a decimal. It's 5.875. Because I'm rounding to two places, I want to keep the 8 and the 7. But actually, that's 7. Because of the 5 after it, the 7 rounds up to an 8. So I'm going to put 5.88. And that's our answer for that one. By the way, before we go on, I just want to explain, what does this mean? What does 5.88 mean from this? It means that if I was to take the number that we got right here, this 5.875, going on forever number, if I was to multiply this by itself 5 times, I should get 7,003. In fact, let's see what happens when I do that real quick. Well, because I rounded, it's going to be a little off, but I'm typing it in 5 times. 5.88 times itself 5 times. By doing that, I should get something really close to 7,003 because I rounded. See that? 7,003. So actually, it's a bit bigger than what I got because I rounded. Because of the rounding, that's why it's a bit bigger than what we have on the inside. That's okay though, because that's what happens when you round. But otherwise, that's how you do this. Or that's the idea behind it. Let's go ahead and do the 10th root of 1,024. Alright, so 10th root, I'm going to have to go back to this button right here. I'm going to hit the Shift. So I have my option to put a number inside the index. So my index is 10 in this case because it's a 10th root. Go over here, I'm going to type in 1,024, and let's see what our answer is. We actually get a nice whole number, that's 2. So our answer for this one, the 10th root of 1,024 is 2. Again, what does that mean? It means that if you take 2 and multiply it by itself 10 times, you'll get 1,024. You can verify that with your calculator. Let me just go on to this one right here. I have 19 to the 1/3 power. Now this is a bit different because it's not using the radical, it's using the exponent. And so on my calculator it's a bit different than most other calculators. My exponent button is this one, the X with the blank square right next to it. When I go to do that, watch what happens on my screen. It puts a box for my exponent. Now I'm doing 19 to the 1/3 power. So when I go to type it in, I'm going to type that as 1 divided by 3. And notice that it's on top. So I'm just trying to get that on there. So it's 19 raised to the power of 1 divided by 3. On some calculators, you're going to need to use parentheses around that fraction. So I'll just show you that. You can do that. I can do that on mine as well. Alright, so 19 to the 1/3 power is 2.6. We're around this second 6 to a 7 because 8 is, 5 or bigger. You should know how to round. So 2.67 for 19 to the 1/3 power. Let's go ahead and do this one and we'll be done with this video. We have 108 to the 2/5 power. 108. Type it in. Focus. Okay. 108. I typed it in. Power button right here. And then to the 2/5, I type in parentheses 2 divided by 5. Close the parentheses. And then there it is. Alright, so I have 6.50, but because this 6 is bigger than 5, this 50 becomes 51. So 6.51. Alright, thank you.